Hi everyone, I'm Jason Tangen. I'm a professor of cognitive science here at UQ, and my research focuses on how we think, learn, make decisions, and how AI can enhance these processes. At UQ, our drive for discovery, breakthroughs, and impact is at the core of what we do. Today, we're facing a massive shift with advancements in artificial intelligence. In this video, I want to show you what this means for us here at UQ and why we can't ignore it. Let me show you what this actually looks like. If our vision is knowledge leadership, then we need to embrace these tools to advance our research, to make our teaching more effective, and to solve problems in ways that we haven't even imagined yet. Now, when most people think of AI tools, they think of a helpful chatbot, which is kind of like a smart version of the old Microsoft Clippy. They worry that it makes mistakes, that it's biased, or that AI companies are after their data. But these models have evolved way beyond the simple chatbots like the ChatGPT you might have played around with early on. They can now input and output text, audio, and video. They're also helping scientists do routine tasks faster by transforming scientific acceleration. In fact, Sakana AI, a startup founded last year by former Google researchers, is working to autonomously conduct scientific research. Their AI systems generate novel ideas, write code, execute the experiments, analyze the results, produce full scientific manuscripts, and even conduct peer reviews of their own work. Sakana AI was just valued at $1.5 billion in their latest funding round. This marks a significant shift in how research is changing. Last week, Jeff Hinton and Denis Hassabis were each awarded Nobel Prizes in physics and chemistry for their work on AI, which shows how these tools are being integrated. The size and sophistication of these base models are improving at an exponential rate, with no sign of slowing down. The next generation, models like GPT-5, Claude 4, Gemini 2, are all due shortly after the US election or early next year. In the meantime, OpenAI has just released a new class of models called O1, which represents a whole new paradigm. Instead of being trained on a huge set of final answers, O1 actually learned from the reasoning steps that led to these correct solutions. So it actually takes time to think through each of the various steps before arriving at a final answer. So right now, we all have basic access to the preview version of this O1 model, but already academics are using it to solve problems.
Here I would ask a question about the application of a certain quantum operator, which I know previous models like GPT-4 would very likely fail in this task. But here, in contrast to answers from GPT-4, this one gives me very detailed mathematics. This is correct. That makes sense. Here I think it tries to do something incredibly difficult.
So the decrease trait synthase activity, this is really smart because I don't know from this variant if it's like knocking down activity or causing too much activity. It's actually really hard to figure that out sometimes. And so it gives both options. So I can think about both ways that it could be going. That's actually really cool.
So yeah, it's very clever. It says, please note while diabetes was suspected, it was ruled out based on the normal HbA1c level and therefore does not constitute the diagnosis. I mean, this is amazing.
No chance. Come on. There's no way. There's no way. What line are you in? 208. Oh my god, it ran! Oh my god, it ran! That's literally what my code does. It ran. Yeah, I mean, if it can 6-shot or 7-shot, however long it took, my 1,000-line code and do it in like 20% of the length. I mean, what's the point for me, right? I feel like I want to apologize to my PhD advisor. Like, I'm sorry you didn't have ChatGPT 01 in 2018. Could have saved you a full year talking to Kyle.
So O1 performs quite well on a range of benchmarks, including on PhD-level science questions, where it even outperforms human experts. And this O1 preview model is just the beginning. It shows that as we add more computational power to train the models and give them more time to think, their performance scales exponentially. And these curves aren't slowing down. Noam Brown, who helped develop this model at OpenAI, said that O1 thinks for seconds, but they aim for future versions to think for hours, days, even weeks. Inference costs will be higher, but what cost would you pay for a new cancer drug, for breakthrough batteries, for a proof of the Raman hypothesis? AI can be more than just chatbots. At a recent AI summit here in Brisbane, I was chatting with one of the top researchers at Google DeepMind who's scaling their language models. And he told me that AI labs have realized that to keep leveling up and challenge these AIs on the hardest problems, they need to recruit top experts in the fields because they're hitting the ceiling on these benchmarks. Here at UQ, we've had a somewhat narrow view of these models, and we focus primarily on students cheating. Now, cheating is obviously a concern that needs to be addressed, but I think we're missing out on so much more. We need to start exploring much more of what these intelligent systems have to offer. In teaching, there are several teaching innovation projects which are making a lot of headway, but I've barely touched on the implications of these models for teaching. With AI avatars like this, we can create lectures that are not only visually stunning, but potentially more engaging than our own. 人工智能现在可以用任何语言教授课程，这将彻底改变我们的教学方式。And these avatars can take on any form, highlighting just how flexible and advanced these models have become. And I think they look pretty convincing right now, but they're only going to get better. In research, we need to think more about how we can use these models to conduct better, faster, and more transparent research. And there are less obvious applications, like creating an AI that's specifically trained on previous grant proposals to increase our chances of funding, or scouring our publications for commercialization opportunities. And for engagement, we could easily build an AI model on the back of eSpace, where all of our publications are automatically uploaded. It could generate a headline for every paper we publish that's automatically fed to the media and comms team to see what's newsworthy. It could convert them into social media posts, plain language summaries, or even press releases. There are dozens of systems across the university where we could push relevant content to people instead of having them seek it out, from contracts and legal to HDR milestones, UQ advancement, research integrity, or early warning systems for student retention or mental health support. Or maybe we could try using it to draft a strategic plan for how to keep pace with these developments. Here's a strategic plan for AI integration that O1 generated in just a few minutes, which I'll link to below. The first step is to get everyone using these tools and exploring their capabilities. But learning to use these tools is kind of like learning how to drive. You can read as many manuals as you'd like or watch other people do it, but the only way to learn is to spend time actually doing it, figuring out what it can and can't do, and trying it out on various aspects of your work. But for people to explore and learn how to use these tools effectively, everyone needs access to the most powerful models, like ChatGPT EDU, which is specifically designed for universities, Anthropic's Claude, or Google Gemini, and maybe a combination. And everyone's going to need much more encouragement from the senior executive to use these tools. Now, there's a handful of people who are extremely close to the development of the most capable models who are making some very bold predictions about how AI is going to change our lives in the next 5 to 10 years, around the same time as the Brisbane Olympics. But even if these predictions are 10 years off in the conservative end, and it takes 20 years to achieve powerful AI that can produce these sort of outcomes, many, or hopefully all of us, will be around to witness these sort of changes. But what does this mean for us here at UQ? Well, it's a wake-up call for sure, but it's also an incredible opportunity. By integrating AI into our research, our teaching, and our engagement in ways that make sense, we can do more than just keep up. We can lead the way. But to get there, I think we need to start experimenting and encouraging everyone to explore these tools for themselves. AI is here. It's powerful. So let's use it. Thanks for watching.